Hello, and welcome to the first in a series of short videos on simplifying formal. My name is Pete Hardee. I'm the Product Management Director for JasperGold Formal Verification Platform at Cadence. In this introduction, I'll explain what formal verification is and how it differs from other, perhaps more familiar verification methods like simulation. Please check back for more videos in this series to hear some of my colleagues introduce various aspects of formal verification. So formal is a key component in the verification suite from Cadence, and that verification suite is optimized to find and fix the most bugs per dollar invested in bare metal compute. The suite consists of four main verification engines, two software engines, that's JasperGold Formal and Excellium Simulation, and two engines based on a hardware platform, and that's Palladium Emulation and Protium Prototyping. The last two can be used later in the process for full chip verification with the software stack. But first, let's go a little deeper into simulation. The tests are based on dynamic stimulus and checkers. So really, it's the quality of the test bench that is controlling the overall verification effectiveness. Some directed tests can be run early, but in general, the verification engineer is developing quite a complex test bench, which will be complete later in the process. The advantage of simulation is it scales pretty well beyond block and IP level to full system integration tests. Formal, on the other hand, is based on mathematically proving properties. The tool will exercise automatically all input combinations without a test bench, and this helps to shift verification left. You don't have to wait for the test bench to be available. The historic limitation has been that scalability beyond block and IP level has been difficult, but a lot has changed over the last 10 years. There's been huge progress in model checking scalability and performance, and that's really driven formal verification into the mainstream as a tool in the verification toolkit. So let's take a deeper look at how simulation works. It very much depends on the test bench, as we said, and the DUT, the design and the test, is explored only where the stimulus drives it. You need the checkers to check for the bugs. It's very much a depth first technique. On the other hand, formal is breadth first. Formal will explore every combination of inputs one cycle at a time, while exploring a property or assertion, very much a breadth first search. And as it's exploring these properties, there are really three possible outcomes. Either a counterexample is found, and that's a potential bug. The property may be fully proven, or there may be a result in between where the property is inconclusive, it does not converge. That might be a useful result, depends how many cycles it gets into the state space. It could be a so-called useful bounded proof. Or you might want that property to converge, in which case you can reduce the state space through constraints or design abstractions, or you can change the property by simplifying the property or applying helper properties that help the property to converge. JasperGold is the easiest formal verification to adopt for two main reasons. One is the range of apps we have. The main model checking app is formal property verification app. That's where you write the properties for yourself. But all the other apps generate properties automatically, either directly from the RTL design or from some higher level spec. Combine that with a very intuitive formal debug environment we have called Visualize. And this is really driving formal verification usage. We're seeing a 16% CAGR in terms of the user growth over the last 4 years. So in summary, formal is a mainstream solution in the verification toolkit. JasperGold is adopted broadly. Actually, 19 out of the top 20 semiconductors are using JasperGold. It's the fastest and most scalable formal verification platform and the easiest to adopt because of the range of apps and also the visualized debug environment. Thanks for watching this video, and check back for more videos coming in this Simplifying Formal series.